Okay, pre-cal, we are at function operations. This is your first video for 1.6, and we are just going to go through here and talk about this. This is pretty easy. Function operations, as the name would imply, that just means operations. So our familiar operations from little kid school, adding, subtracting, multiplication, and division. So you can do that with two functions. That's called function operations. So if I give you f of x equals x to the third and g of x equals the square root of x, I'm going to find the formulas for f plus g and f minus g. So f plus g means I'm going to take f of x plus g of x. So that just means my function is going to be x to the third plus the square root of x. Now, x to the third and the square root of x are not like terms, so that's the answer. But we also need to give the domain of each one. Now, this is where things get a little tricky. Okay, so we're going to write our domain in this notation right here. Okay, so it's set notation. All right, so it's all of x such that x is limited because of this square root right here. Now, if you'll remember from algebra, a square root, we can't take the square root of a negative, so the square root has to be positive. So x in a radical has to be positive. So that means that we can only have our positive values for x. So x has to be greater than or equal to 0. All right, and then when we look at f minus g, I'm going to switch colors here so we can make a distinguish. So we can distinguish between them. Ugh, I'm tired. Sorry, kids. So we've got f of x minus g of x. So that's just going to be x to the third minus the square root of x. And the domain for that is going to be exactly the same thing. Awesome. Okay, so when we look at number 2, we've got f of x here and g of x. We're finding the formulas for f times g. So that would be f of x times g of x, which is going to give me x cubed plus 2x squared. I'm going to put all that in parentheses, times 3x squared minus 1. All right, so we're going to have to FOIL, if you remember how to do that from Algebra 2. That just means every term over here gets multiplied by every term over here. All right, so what is that going to look like, Miss Griggs? Well, it's going to look just like this. X cubed times 3x squared. Remember your rules for exponents. When we're multiplying, my exponents do what? They add. Okay, so I've got 3x to the 5th, and then I'm going to multiply x to the 3rd times -1, and that gives me negative x to the 3rd. 2x squared times 3x squared gives me 6x to the 4th. And then 2x squared times -1, negative 2x squared. Okay, so there's my solution. I'm going to go ahead and put this in descending order just because that's good math practice. So I'm just going to move this over. And we don't have any fractions, and we don't have a square root, so my domain would just be all real numbers, or you can write it in infinity, however you want to write that. All right, so the next one is f divided by g. Okay, so I've got f of x divided by g of x. So x cubed plus 2x squared divided by 3x squared minus 1. Okay, now a lot of students have trouble with this because they want to go ahead and cross out this x squared here with this x squared up here. Well, you can't do that because you've got addition up here. Oh, man. That's why I can't have anything nice. Just saying. Sorry, kids. I don't know what I was thinking. Anyway, so this x squared can't reduce with this x squared in the numerator because you've got addition and subtraction here. You can only reduce when you've got all multiplication and division, so pay attention to that. So my function is just that. It's not very pretty. It's kind of ugly, but it's okay. We'll get over it. All right, so notice there's a fraction. Remember the cardinal rule in math. You can't divide by 0. Can't divide by 0. Now, a lot of students get confused on this too. They think that x can't be 0. Well, that's not true, because if x were 0, I would have a negative 1 in the denominator, and that's perfectly acceptable. So I want to make sure that 3x squared minus 1 doesn't equal 0. So I don't want x to be any value that causes all of this math to become 0. So how do I do that, Miss Griggs? Well, this is how you do it. You solve for this. You solve x. So I'm going to add 1 to both sides here. And then I've got 1/3. And then I've got to take the square root of 1/3. So it's essentially plus or minus the square root of 1/3. For now, I just want you to leave it that way. There's a prettier way and a better way to write it, but we'll address that later. So when I'm writing my domain for this, it's going to look a little weird. So here's the thing. There are only two values x can't be, the square root of 1/3 and the negative square root of 1/3. So I'm going to write it this way: from negative infinity to negative square root of 1/3, and then in between negative square root of 1/3 and positive square root of 1/3, there are values. So it skips over those, and then the square root of 1/3 to positive infinity. I know it's ugly. I'm sorry, and I ran out of room up there. It's very disappointing. Okay, so number 3, we have f of x equals negative x squared minus 3x plus 4, and we have gx equals negative 2x squared plus 10x plus 3. So I'm being asked to find the formulas of 2f of x minus 3g of x. So that essentially means I'm going to multiply 2 by this right here, this f of x. And then, see, I'm going to subtract 3, and 3 gets multiplied by all of this, so g of x. So essentially all I have to do here is just do some distribution and then combine like terms. So I'm going to distribute my 2 to each of these terms, so that gives me negative 2x squared minus 6x plus 8. Be careful, this is a negative 3. The whole thing gets distributed to all 3 of these terms. So negative 3 times negative 2 is positive 6x squared. Negative 3 times 10x is negative 30x. Negative 3 times 3, is negative 9. And now I'm going to combine like terms. So I have negative 2x squared and 6x squared. So that is going to give me 4x squared. I have negative 6x and negative 30x. That's negative 36x. And now I have 8 and negative 9, and that's negative 1. And my domain, no fractions, no square roots. So it's all real numbers. Awesome.